My name is Blake Terry. I just wanted to create a video kind of demonstration with the product that I have currently. As I've mentioned, this is not the version that's going to market, but I just want to provide a demonstration as to why this product is necessary. So I'll start with how patients usually address a new frontal walker or assistive device that's placed in front of them. We, as therapists, I'm a PTA, been doing it for 11 years and everything, and then actually been a caregiver for quite a few family members as well over the years. When you place the frontal walker or assistive device in front of a patient, a lot of patients tend to think this to be like a stable structure or something that they can pull on to help bring themselves to a standing position. And just to provide a demonstration, so like a patient, you get this in front of them, they're like, oh, I can grab this, and then they usually tilt it back and utilizes that as leverage to come to a standing position like that. Now that alarm is the feedback system that I have, so just disregard that. So this is that's an example of what they do. By doing that though, they increase their risk for falls, which it goes up, quite a bit just by doing that, because it can translate over into other things, like whenever they're in the bathroom and they grab on the sink, or they have a table with where you have your food, the tray and stuff, they may try to grab that. I've seen it before. And my grandfather even had the fall similar, like he used the frontal walker as leverage to come to a standing position, rotated, and an arm like this on a chair, you can fall over, and that's what had happened to him. But it's happened to many other patients. So we really emphasize our training as therapists. We're trying to prevent patients from doing that, because all it takes, even if they can complete that transfer by using that as a tactic, all it takes is one slight rotation and then they fall. So the purpose of this feedback system is to provide reinforcement when the therapist or healthcare provider cannot be there. So what I made essentially was a feedback system so with this version, this is the mechanical version, as I said, mechanical electrical version that was strictly made for the clinical setting. So more so with surfaces where it's tiled floors, flat surfaces, no thresholds between doors. And we made this for the National Science Foundation project so we could do testing and stuff with. So we had some of our study with it. We did it with another product that was made, and we tested it with our patients that came to the facility. So with this one, you have essentially a linear actuator. So when the tilt occurs, this rod gets pushed and compressed in on a push button switch that's ran up to the console, which when the alert occurs, a red light, so an audible and visual cue goes off. Now with the version that I have that I'm going to market with, we have designed an infrared sensor that would go inside this front leg of the walker, and when the walker comes about an inch off the ground tilt like that, that infrared sensor is programmed to pick up on that, and the PCB, everything is designed in the console. On my version, it's built into this front bar. Like I said, this is just for demonstration, so this is just the prototype from the beginning. But that would alert the patient. There's a voice command that goes off, and it'll say caution, instability, compromised, please correct. Whenever I have it, I'll be able to demonstrate that one as well. But for this version, so I'll give you the why, what it would reinforce with our training, essentially as a therapist. So what's taught whenever a patient gets the frontal walker, typically they should be fitted for the frontal walker right away. You got to get the height right. Depending on the weight, you got to select the proper frontal walker. So the bariatric version versus the standard version a lot of the times. So you get all of that set up as a therapist in the beginning. Then you start to teach them how to engage the assistive device. So, meaning like when they're sitting, to transition from a sit to stand position, you have to teach them how to compensate for it when they lack lower extremity strength, or if they have any other kind of health condition, problem with that. So what we would have them do is you scoot your bottom to the edge of the seat, bring your feet up underneath you, then you take both hands and place them on the armrest. If the seat does not have that, you still want to push from the surface, but you utilize your upper extremities to compensate for that lack of strength in your lower extremities. So you push, we always say nose over your toes, so bring your nose over your toes too. So you got to lean forward and you push to stand. But when you stand, we always want patients to come to a complete standing position, then grab the walker. That way you can proceed with walking. Now, during our study with the National Science Foundation, we actually found that adding this device, patients actually came to a standing position with the feedback system on the device. So they came to a standing position before they started walking. Prior to that, with just the front wheel walker, patients were grabbing onto the walker and tilting it back to help themselves stand up. Then they would not be completely standing erect whenever they started walking. So essentially they were already walking before they were completely standing. So they're at a increased fall risk potential right there. So just adding the system, it actually kind of made the patients monitor the device, and they were almost like, oh, somebody's watching me, so now I need to do this right. So in a way, that's how I felt with it, because all this is to reinforce training for therapists, healthcare providers, and provide some additional feedback to the patient to increase their safety.